Hello everyone, welcome back to my channel Infinity by Yashaswini. What if I tell you that two numbers can reveal their hidden DNA? What if I tell you that prime numbers act like the atoms of mathematics? And can a power of 6 ever end with zeros? Today we are going to solve entire exercise 1.1 of real numbers in the easiest and most interesting way possible. Stay till the end because question 5 and question 6 are favorite board exam questions and many students lose marks here. And in this video, we are going to learn about complete exercise 1.1, board exam tricks, important questions, exam tips, and the common mistakes students make. Let's begin. Suppose these blocks are numbers. Every large number can be broken into smaller building blocks. For example, 60 is broken into 2 into 2 into 3 into 5. So these small blocks are called as prime numbers. Just like every house is built using bricks, every number is built using prime number. Let us just revise Euclid's division lemma. We know that A is equal to BQ plus R, where R is less than B and greater than or equal to 0. Here R is a remainder and B is a divisor and A is a dividend. For example, we can write 243 as 18 into 13 plus 9, where 9 is a remainder and the condition also satisfied, that is 9 is less than 18 and greater or equal to 0. This is Euclid's division lemma, fundamental theorem of arithmetic. As we know, every composite number can be expressed as a prime numbers and their factorization is unique except for the order of factors. Here, see, 60 is a composite number. We expressed 60 as a product of prime numbers. These 2, 3, 5 are prime numbers. Like that, every composite number can be expressed as a product of prime numbers. Order may be changed. That is, you can write 3 first or 2 next, but usually we write always in an ascending order of prime numbers, and each composite number has an unique prime factorization. Now let's move on to the exercise problems. Here the first question is, express each number as a product of its prime factors. Here 140 is there. We have to express 140 as a product of prime factors. How to express this? It means we can divide 140 as 2 into 70. 70 can be expressed as 2 into 35. Then 35 can be expressed as 5 into 7. We cannot further divide 7, so we can write 140 as 140 is equal to 2 into 2 into 5 into 7. So this is the way of expressing a number as a product of its prime factors. Easy, right? Let's move on to the next one. 156. How to express 150 as a product of its prime factor means we can divide 156 as 2 times of 78. Again 78 we can divide it as 2 times of 39. Again 39 we can write it as 3 times of 13. Further we cannot divide this, so we can express 156 as 2 into all these are prime numbers. So 2 into 2 into 3 into 13. Right. Now we'll move on to the next question, that is 3825. When you are expressing 3825, you know the divisibility rule. When a number ends with 5 or 0, it is divisible by 5. So we can divide 3825 by 5. If you are not comfortable in dividing with the tree method, we can use this method. That is, see, you can start dividing from 5. So 3 is less than 5. So we can take 2 digits at a time. That is 38. We know that 5 7 times is 35. And what is the remainder here? We get remainder as 3. Now this becomes 32. 5 6 time is 30 and 2 is a remainder. So you can write 2 here. Then it becomes 25. Now you have 5. 5 time is 25. We got 765. Again, this number is divisible by 5. Now, first digit is greater than 5, so we can one digit, that is 5. One time is 5. What is the remainder here? Yes, 2 is a remainder. Now it becomes 26. 5. 5 time is 25. 26 minus 25 is 1. So 1 is the remainder. Now it becomes 15. 5 3 time is 15. 153 is not divisible by 5. So you know the divisibility rule of 3. When you add all the digits, if it is divisible by 3, then the whole number is divisible by 3. So 1 plus 5 is 6, 6 plus 3 is 9. So 9 is divisible by 3. So entire number is divisible by 3. 3 5 time is 50. Now 3 1 time is 3. 51. Again 51 is divisible by 3. How? 5 plus 1 is 6. 6 comes in 3 table. So it is divisible by 3. 1 time is 3. Now 2 is the remainder. So it becomes 21. 5 7 time is 21. 17. 17 is not divisible by any number. It is divisible by 17 only because it is a prime number. Now we can express 3825 as here 5 comes 2 times. So 5 into 5 and 3 comes 2 times. So 3 into 3 then 17. Let us express in their powers. That is 5 comes 2 times. So 5 power 2 into 3 comes 2 times. 3 power 2 into 17. Remember that while you are expressing a composite number as a product of prime numbers, always express in an ascending order. So we can write it as 3 square into 5 square into 17. Let's move on to another number, that is 5005. See here 5005. A number ends with 5 means it is obviously divisible by 5. 5 one time is 5. Here 0 is there. 5 0 time. 0 time. Again here 5 is there. 5 one time. Then from which number 1001 is divisible? It is not even divisible by 2 because it is not an even number. Not by 3 because 1 plus 0 plus 0 plus 1 is 2, which is not comes under 3 table or which is not divisible by 3. Then even it is not divisible by 5. Then from which number we have to check? The next number is 7. So we'll do with 7. So we'll divide by 7. 7 one time is 7 and 10 minus 7 is 3 and 3 is a carry and this become 30. 7 4 time is 28. 30 minus 28 is 2. So 2 is a so 2 is a carry. Then this become 21. Then 7 3 time is 21. Then 143 we can divide it by 11. 11 one time is 11. 14 minus 11 is 3 and this become 33. Now 11 3 time is 33. 13 is a prime number, so 13 one time. Now we divided completely. Let us express this as a product of prime, that is 5005 is equal to 5 into 7 into 11 into 13. Already it is in an ascending order. 5 into 7 into 11 into 13 is the answer. Easy, right? Now let us move on to the next one, that is 7429. It is divisible by 17. 17 4 time is 68. 74 minus 68 is 6. So 6 is the remainder. Now it becomes 62. Now 17 3 time is 51. 62 minus 51 is 11. 11 is the carry. Now it is 119. 17 7 time is 190. Then 437 is divisible by 19. 19 2 time is 38. 38 minus 43 is 5. Now it become 57. Now 19 3 time is 57. Now 23 comes. 23 is a prime number, so 23 one time is 23. Now we can express 7429 as 17 into 19 into 23. To know the divisibility rule, just check my YouTube shorts. I made few videos on divisibility rule. The important exam tip is always write numbers in ascending order. As I told you, always express the prime numbers in an ascending order. Now it's your turn. Now pause the video and factorize 84. Have you got the answer? Let's check the answer. If you got 2 square into 3 into 7, you are correct. Before going to second question, you must remember one thing, that is when you are finding HCF, always take a common factors with smallest powers, and if you are calculating LCM, all factors with greater powers or large powers. So HCF smaller powers and LCM larger power. Now we'll move on to the second main. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to the product of two numbers. Here we have to find the LCM and HCF of these two numbers, and then we have to verify that LCM into HCF is equal to the product of these two numbers. The first will find the LCM and HCF. Before finding LCM and HCF, you have to express the given numbers as the product of prime numbers. How to express 26 as a product of prime numbers? We can divide 26 as 2 times of 13, right? And 13 is a prime number. Further, we cannot divide. So 2 times of 13. Now 91. 91 is divisible by 7. So 7 times 13. Now we expressed the number as a product of prime factors. Now to find the HCF, you must remember that we have to choose the common factor with the smallest power. So here the common factors are 13. Therefore HCF is 13. What is the LCM here? LCM is all factors with greatest power. HCF is common factors with smallest powers, and LCM is all factors with greatest power. All factors means here 2 into 13 into 7. Only one time you have to take 13 here. So 2 into 13 into 7 is 182. So LCM is 182. In the next step, we have to verify that whether the product of LCM and HCF is equal to the product of the two numbers. First, we'll find HCF times LCM. HCF is 13 and LCM is 182. If you multiply HCF and LCM, 13 types of 182 is 2366. So this become an LHS. Now we'll move on to an RHS, that is the product of two numbers. So 26 into 91. This is LHS and it is RHS. Therefore, we can say HCF into LCM is equal to the product of two numbers. Let us solve one more problem. Here 510 and 92. First step is express the two numbers as a product of prime factors. That is, express 510 as a product of prime factors. It is divisible by 5. 5 one time is 5. Now 1 is less than 5. Many of the students take directly 10, but we cannot take two numbers in the middle or at the end of the problem. While you are taking two numbers, you have to write 0, or we can write 5. 0 time is 0, then 1 is carry. Then this become 10. Now 5 2 time is 10. 1 or 2 is divisible by 2 because it is an even number. 2 5 time is 10 and 2 1 time is 2. Now 51 is divisible by 3. 3 1 time is 3 and 2 is a remainder and this become 21. Now 3 7 time is 21. Now 17 1 time. How can we express 5 into 2 into 3 into 17, but always express in an ascending order, that is 2 into 3 into 5 into 17, right? Now let us express 92. 92 is divisible by 2. 2 4 time, 2 6 time, again from 2, 2 2 time, 2 3 time. Now 23 is a prime number, further we cannot divide, so 23 one time. Till you get 1, you have to divide it. Then 92 can be expressed as 2 times 2 into 23. Now we can express this as a powers. 2 comes 2 times, like so 2 to the power 2 into 23. Now what is HCF? Common factor with smallest power. Among these two, which is common? Only 2 is common, but here 2 is having the power 2 and here 1. So we have to consider always the smallest power. So 2 power 1 is nothing but 2. 2 is an HCF. Now LCM. LCM is all factors with greatest power. So in 2, which is the greatest power? 2 square, then 3 times 5 times 17, then 23. When you multiply all these numbers, you will get 23,460. So the LCM is 23,460. Now we'll verify whether the product of HCF and LCM is equal to the product of two numbers or not. HCF into LCM or LCM into HCF is equal to 2 into 23,460. That is 46,920. So LHS is 46,920. Now we'll find the product of 510 and 92, which is an RHS. So when you multiply 510 and 92, you will get 46,920. Therefore, LHS is equal to RHS. So it is verified, right? LCM into HCF is always equal to the product of two numbers. Let's solve one more problem. You solve along with me. Now, what is the first step here? First step is we have to express the two numbers as the product of prime numbers. That is 336. 336 is divisible by 2. 2 one time is 2. 1 is carry, then become 13. Then 6 time. 1 is carry, then it becomes 16. 8 time. Now 2 8 time is 16. Then 2 4 time. Again from 2. 4 time. 2 time, again from 2, 2 time, 1 time. Now it is divisible by 3, 3 7 time, now 7 1 time. Now how you are expressing it? Directly you can express this with the powers. 2 comes how many times? 4 times. So 2 to the power 4 into 3 into 7, right? Now we'll express 54. 54 is divisible by 2, that is 2 2 time is 4 and 1 carry, now 7 time. It is divisible by 3, 3 9 time, again 3 3 time, 3 1 time. Now how we are expressing 54? As 2 comes 1 time, so 2 to the power 1, or just you can write 2. Now 3 comes how many times? 3 times, so 3 to the power 3. What is the HCF here? HCF is common factor with the lowest power. Here which are common? 2 is common and 3 is common. And into which is the smallest power? 1. So 2 power 1 into here in 3, which is the smallest power? 3 to the power 1. So 3 to the power 1. Now 2 times 3 is 6. So HCF is 6. And LCM. LCM is all the factors with their greatest power. 2, 3, 7 are the three different factors. Now 2, which is the highest power? 4, and in 3, which is the highest power? 3, and in 7 only one 7 is there. Now multiply 2 to the power 4 into 3 to the power 3 into 7. 2 to the power 4 is 16. When you multiply 2 4 times, you will get 16. When you multiply 3 3 times, you will get 27, because 3 3s are 9, 9 3s are 27 into 7. Now multiply everything, you will get 3024. So HCF is 6 and LCM is 3024. Let us verify whether LCM into HCF is equal to the product of two numbers or not. LCM into HCF, that is equal to LCM is 3024 and HCF is 6. So 3024 times 6 is 18,144. Now we'll find the product of 336 and 54. 336 into 54 is again 18,444. See, both the answers are same. So we can say that LCM into HCF is equal to product of two numbers. In these three problems, you have to keep in mind a quick trick, that is HCF is common factor with the smaller power and LCM is all factors with large power. That is HCF is humble and LCM is large. Easy to remember, right? Now let us move on to the third main. Find the LCM and HCF of the following integers by applying prime factorization method. Here three numbers were given. Remember one thing, when there are three numbers, the same condition, that is LCM into HCF is equal to the product of numbers, na? It won't be applicable for when we are having more than two terms. It applicable only for two terms. So there are three different terms. We have to find the LCM and HCF of these three numbers. First, find the factors of 12. 12 can be expressed as, you know that 12 can be written as 2 6 times. Again, 6 can be written as 2 3 times. So 2 comes how many times? 2 times, right? So 2 to the power 2 into 3 comes 1 time. So 3. Now 15. How to express 15? It is easy. 3 5 times is 15. So 3 into 5. Then 21. How to express 21? 3 7 times is 21. Now we expressed all the numbers as a product of prime numbers. Now let us find HCF and LCM. To find HCF, what is the rule? We have to remember common factor with lowest power. Here only the common factor is 3. Therefore, 3 is an HCF. When you don't have any common factor, then 1 is the HCF. Now LCM. LCM is all the factors with larger power. Here the first factor is 2. 2 has a larger power. Then 3 is having the power 1. Then 5 into 7. Now multiply everything. When you multiply everything, you will get 420 as an answer. HCF is equal to 3 and LCM is equal to 420. Let us move on to the next one. Here 17, 23, 29. 17 is a prime number, so 17 itself is a factor. Then 23 is also a prime number, so 23, and 29 is also a prime number, so 29. See, there is no common factor. Now what we have to do for HCF? When you don't have any common factor, then HCF is equal to 1. Now LCM, multiply all factors, that is 17 into 23 into 29. When you multiply 17, 23 and 29, you will get 11,339. So LCM is 11,339 and HCF is 1. So here only one thing you must remember, that is when you don't have any common factors, then 1 is the HCF. Now we'll move on to the next one, that is find the HCF and LCM of 8, 9 and 25. What are the factors of 8? 8 can be written as 2 into 2 into 2. That is 2 to the 4, 4 to the 8, or 2 to the power 3. Now 9 can be expressed as 3 times 3 or 3 to the power 2. Now 25. 25 is 5, 5 times is 25, 5 square. See, here also there is no common factors. Here 2, 3 and 5. There is no common factor. What is the HCF then? HCF is equal to 1. Now LCM is all the factors with greatest power, that is 2 power 3, power 2 and 5 power, that is 3 power 3 is 8 into 9 into 25. When you multiply all the three number, what you will get? And the answer is 1800. In this problem and in the previous problem, what you observe, when you don't have any common factors, then HCF is 1 and LCM is the product of the given numbers. Right? Here also we multiplied these three numbers. And in the previous problem also we multiplied these three numbers. So when you don't have any common factors, then HCF is equal to 1 and LCM is the product of the given numbers. Seems to be easy, right? Let's solve the fourth problem. Given that HCF of 306 and 657 is 9, find the LCM. When you have the HCF and LCM of two numbers, we know the formula, that is LCM into HCF is equal to the product of two numbers, right? Directly you can apply this. Here, what is the HCF? 9. LCM we have to find that. So we don't know what is LCM, write LCM as LCM only. Then the product of two numbers. Which are the two numbers? 306 into 657. Now we have to find LCM. If 9 to RHS, then it become 306 into 657 divided by 9. See here, this is divisible by 9. So 9 one time, 9 three time is 27. Now 36 it become, and 9 four time is 36. So what is remaining here? 34 into 657. Now multiply 34 into 657, you will get the LCM. Have you got 22,338? Then you are correct. Easy, right? When they given two numbers and either HCF or LCM, it is easy to find the required number, right? Here you must remember this LCM into HCF is always equal to the product of two numbers. Now let's solve this fifth question, which is very important for your board examination. Check whether 6 power n can end with the digit 0 for any natural numbers n. Can a power of 6 ever end with zeros? For any number to end in 0, it must contain 2 and 5 as factors. Whether they may give 6, 8, 10, any number, it must contain 2 and 5 as a factor. Now, what are the factors of 6? 2 into 3 is 6. So, 2 and 3 are the factors. Now here 6 power n is there. So 6 power n is equal to 2 power n into 3 power n. There is no factor 5, right, in this number. Hence, we can say that 6 power n can never end with 0. So, if a number ends with 0 means it must contain 2 and 5 as factors. Here we have 2, but there is no 5. So, 6 power n can never end with 0. I'll show you few examples. 6 power 1 is 6. Then 6 power 2 is, in the place of n, I'm replacing the n by numbers, natural numbers. So 6 power 1 is 6, 6 power 2 is 36, 6 power 3 is 216, then 6 power 4 is 1296. See, there is no 0, right? So 6 power n can never end with the digit 0. Interesting, right? Now we'll move on to one of the most favorite board question, that is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Oh my god, it looks quite difficult, right? Trust me, it is not. Let's solve the first one, that is 7 into 11 into 13 plus 13. See, among these two, these are the different terms. Among these two, which is common here? 13 is common. So take 13 as common, then this become 7 into 11 into 13 become 1, because we have taken it as common. 13 of 7 into 11 into 1 is 77 plus 1. Now which is equal to 13 of 78. Now find the factors of 78. That is, it is divisible by 2. That is 2 3 time is 6, 1 carry, then it become 18, 2 9 time. Now 39 is divisible by 3. 3 1 time and 3 3 time. Again 13 1 time. Into 78 can be expressed as 2 into 3 into 13. Arrange in an ascending order. That is 2 into 3 into 13 comes how many times? 2 times. That is 13 to the power 2. So we know that according to the Euclid's fundamental theorem of arithmetic, every composite numbers can be expressed as a product of prime numbers. See, these are the product of prime numbers, means obviously it is a composite number. Hence proof. Quite interesting, right? Let's solve one more problem. That is the second one. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. See, this is one term and this is another term. Now in this 5 is common, right? So let's take 5 as common. That is 7 into 6 into, we have taken 5 as common. So 1 is remaining. then 4 into 3 into 2 into 1. Plus here also 5 we have taken common, so it become 1. Now multiply everything. That is 7 into 6 into 1 into 4 into 3 into 2 into 1. We will get 1008. Plus here 1 is there. So 1008 plus 1. 1008 plus 1 is 1009. Here 1009 itself is a prime number. So 5 times of 1009. We expressed it as a product of prime number. Therefore, the given number is a composite number. Now let's move on to the one of the interesting problem of the day. These kind of question you may get in your board exam. See here, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So to understand this problem, visual understanding is required. Okay, see here, consider this as a Sania's car and this as Ravi's car. So both are starting at the same point and Sonia takes how many minutes? 18 minutes to drive one round and Ravi takes 12 minutes to drive one round. Now, if both are starting at the same time and the same point, at what time they both will meet? So we have to find that, right? So how to find it? When you have to calculate at what time they meet together. See, when they start to drive at the same time and the same point, to check when they'll meet, we have to find the LCM of the two numbers. Here Sonia, she takes 18 minutes, right? And Ravi takes 12 minutes. We have to find at what time they both meet at the same point. Now to calculate this, we have to take LCM of 18 and 12. To take an LCM of 18 and 12, first find the factors of 18. 18 factors of 2 into 3 into 3, that is 2 into 3 power 2. And 12 factors are 2 into 2 into 3, that is 2 power 2 into 3. Now, how to find the LCM? Always LCM is equal to all factors with greatest power. Here, 2 with the larger power is 2 power 2 into 3 with the larger power is 3 power 2. 2 power 2 into 3 power 2. That is 4 in times 9. That is 36. So they meet after 36 minutes. So after how many minutes they meet? After 36 minutes, they both meet at the starting point. These are the challenge questions. Try all these questions and comment your answer below. Let's discuss the common mistake that students make during examination or during calculation. The first one is writing LCM instead of HCF. You may confused with what is HCF and LCM. Always keep in mind that HCF is common factor with the smaller powers and LCM is all factors with larger power. Then forgetting prime factorization. Prime factorization is very important. Always divide the given number from the prime numbers. Then taking highest powers in HCF. Always remember HCF is the smallest power and LCM is highest power. Then calculation mistakes, cross verify 2-3 times while doing calculation. Don't make any calculation mistake. By practice, you may fix it. And forgetting verification. Once you are done with your answers, again cross verify the answer. You may made some error or mistake here and there. So to fix it, always do the verification. Let us have a quick summary. That is, according to Euclid's division lemma, A is equal to B into Q plus R. That is, dividend is equal to divisor into quotient plus a remainder, where remainder is lesser than the divisor and greater than or equal to 0. And HCF is always the smallest power and LCM is the highest power of all factors. And this is common factors. And product formula, you must remember that the product of HCF and LCM is always equal to the product of two numbers and prime factors are building blocks. So all composite numbers can be expressed as the product of prime factors, where the prime factors are a building blocks of composite number. Numbers ending with 0 need to have the factors 2 and 5. Like for 6 power n question we solved now, for that kind of question, any questions where they ask whether the given number ends with 0 or not, it must contain the two factors, that is 2 and 5. If this video helped you understand real numbers better, don't forget to like the video, subscribe to the channel and share with your classmates. Comment below which question did you find the most difficult. In the next video, we will revisit irrational numbers. Thank you. Have a great day.